Hey everyone, welcome back. We're going to continue on in our statistics, although this unit will actually wrap this statistics unit up and you'll get into some probability starting next week. So, interpreting data. You're probably not surprised this is kind of where the whole statistics unit leads. We need to look at the data that we're actually talking about and figure out how to interpret it. By the way, this is something that you'll continue to study for years to come in many subjects. If, for example, you're interested in being a sociologist, you want to study the grand movements of people and how they interact, you'll actually end up spending a lot more time studying statistics in college. If, on the other hand, you're not interested in something like that, this is a really good thing to be able to understand because if you haven't noticed, statistics get used a lot in the news, and I want you to be an informed consumer. So, our introduction. The new track. Wow, it looks like we're going to get a new track at the school, Sam said at breakfast as he read the newspaper over his dad's shoulder. It must be because we won at regionals. Yes, the track team, the Hawks, had taken first place at regionals. It was the talk of the town, and the newspaper article seemed to suggest that great things were going to happen as a result. Well, I don't want to disappoint you, Sam, but 53% are for the new track, but there's a 5% margin of error. So we're going to talk about what that means in just a second, his dad explained. What does that have to do with anything? A lot. A margin of error can mean that the survey results aren't completely accurate, or you could say that you can't take them at face value, his dad said. Sam is perplexed. 53% is 53%, or is it? So, margin of error. So, in this lesson, you are going to learn about margin of error, and at the end of the lesson, you will be able to understand how this can impact results. So, we actually see this a lot in politics, and you'll notice it in more and more politics as we go forward. So and so is up 3 points, but the margin of error is actually 4 points. So we don't really know. So we're going to talk about what that really means. In this lesson, you will learn how to complete the following skills. Make population predictions based on representative survey data. So many of you are probably noticing you're getting stuff in the mail about the census right now. By law, by our Constitution, every 10 years we have to count every person in the United States. There are a lot of statisticians, mathematicians who do a lot of statistics, who would really like it if we actually changed this to do a representative sample. What that means is that we would actually be able to take a sort of sample of all of the people out there instead of actually talking to everyone. Right now, we talk to everyone instead of talking to a random grouping where we can make inferences or sort of we can make guesses about a big population based on what we see with a little population. I promise I'm not dying. Use given survey margin of error to determine upper and lower bounds of the interval containing a sample percent in which a population percent is most likely to lie. What we mean is if somebody is up 5 points plus or minus 4, well, they're really up somewhere between 1 and 9. That's the 5 plus or minus the 4. So we want to talk about that interval. Interpret and evaluate conclusions of newspaper or magazine articles containing sample survey results or statistical displays. I want you to understand when you look at a newspaper or a magazine or a news broadcast what they actually mean. And analyze and interpret statistical data organized and displayed in a variety of forms, justifying your own conclusions. So, make population predictions based on representative survey data. Drawing conclusions based on data is a major goal in gathering data. As you have seen, some data can be misleading and some conclusions can be doubtful. For that reason, it's important to keep an eye open for public information that may not be entirely based on data. We must be critical about where information comes from because biases may occur in the sampling methods, survey questions, display methods, and conclusions. Nevertheless, good science and math can lead to valuable information. Let's look at how we can make predictions based on survey data. So what this is saying is you have to be really careful when you're looking at surveys. Sometimes they're really wonderful surveys and sometimes they're pretty lousy. I've actually seen and participated in surveys where they weren't written really well, and because of that, they ended up getting the results they wanted instead of the results that they would get if they were using it unbiased. For example, one obvious example of this is when we actually have if you've ever gotten a call from a politician from, or more accurately, usually one of the parties, and they will ask you a whole bunch of questions. And in the end, they're actually hoping to convince you to vote for somebody, but they'll start it as a survey. These are one of those examples. In that case, they're trying to be misleading, but sometimes it happens by accident. For example, a cellular phone company conducts a random survey in their service area regarding the problems encountered with phone service. They surveyed 700 people with cellular phones in a population of 125,000 people. They find the following results. So why do we do this? Well, if we have to call every person, that's going to be really difficult. There's actually a way to calculate the exact number of people that you need to call to get a representative sample. That's beyond the scope of this course, but for now, know that that exists. So what they're going to do is they're going to talk to 700 people instead of that 1,000. I'm sorry, 125,000. So 39% of people said that it was too expensive. 33% said poor signal. 16 said not enough features, and 12 said ugly design. I don't think they're talking about around here. We'd probably have poor signal being a really big one. So based on their survey, they can extrapolate, or what they really mean is they can make assumptions about the larger group based on the data to the entire population. In other words, when the survey was carried out in a proper manner, they can assume the survey is accurate for the entire population. Proper, by the way, is again that random sampling, that unbiased survey. By the way, random sampling is its whole topic all on its own because it turns out it's not easy to do random sampling. If there are 125,000 people in the population, they can assume the same results in the survey would be true for all of those people. So how many find the phones too expensive with a signal of poor quality? Well, we're going to multiply this percentage. Remember, when we multiply by a percentage to find the percent of a number, we're going to turn it into a decimal. So we'll move the decimal place to 0.39. Multiplied by 125,000 gives us 48,750 people. A lot of people saying that this is too expensive. We can do the same thing with the rest of them. 0.33 times 125,000 gives me this, and so on and so forth. We can also calculate several other features, such as mean, median, and mode. For example, a high school conducts a survey for their foreign language program. They need to know how many sections of each class they need. There are 3,400 students in the high school, and each class can have a maximum of 35 students in it. Of 200 students surveyed, they find the following number of student responses. So instead of asking 3,400 people, they're only going to ask 200. That seems a lot easier in a high school. So they find the following responses. 85 wanted Spanish, 35 French, 39 German, 23 Chinese, and 18 wanted none. In order to apply this information to the entire student body, we're going to use the percentages. So how do they calculate a percent? They said 85 divided by the 200 gave me 42.5%, 35 divided by the 200, and so on and so forth. Then they used that to find the population for the whole school. They took that 34,000 times 0.425. And they calculated how many people wanted to take in the entire school each class. Using this, they're going to divide up by 35 students in each classroom. Anyway, so they're dividing by 35 and they figure out we're going to need 42 Spanish classes, 17 French classes, 14 German classes, and 12 Chinese classes. That's a lot of classes, but this is probably more a university than a high school. This is a pretty big thing. This is a lot of people in each of these classes. Because 35 is the maximum number of students, the number of classes must be rounded up to the next whole number. Classes cannot go over 35 and fractional classes can't be offered. Remember, this is one of those cases you have to think about the answer. You need to round here. Okay, part 2. Given survey margin of error to determine upper and lower bounds of the interval containing a sample percent in which a population percent is most likely to lie. That's a whole lot of gibberish that basically says, look at the interval around we think this is our prediction, but our margin goes here and here. That's it. That's what they're trying to say. First, notice that in this section, we're looking for things that are not true. This is the usual way we think through things, so we must keep this fact in mind as we work. Sorry, this is not the usual. Actually, it is. If you're doing statistics, you always are looking to prove the opposite. It's a little odd, but that's how you do it. As you know, the method of choosing samples is important. The better the sampling method is, the better the data collected. When research is gathered well, its results will be truer for the entire population. Nevertheless, most research companies and surveyors understand that it's actually quite difficult to find a perfect sample. There will always be a margin of error or a percentage in which the true numbers for the entire population may differ. So if you really need to know an answer for something, you may choose to have a bigger sample size to have a smaller margin of error. That's one of the things that you can do to control this. The other is to have more accuracy. We'll talk about that a little further. In other words, a survey company may calculate a margin of error plus or minus 3%. This means that the measurements for the entire population can vary plus or minus 3% from where we actually predict it. It's sort of that, we're here, but we're really here. Okay. So, a survey company reports that 51% of people surveyed said they would vote for candidate X with a margin of error of plus or minus. How sure are you that they're going to win? I'm going to say we're not at all sure. Since the margin of error is plus or minus 3%, it could be as high as 54%, that's the 51 plus 3, or as low as 48%, 51 minus the 3. So, if you're winning by 48% to 54%, that's not bad, but it's not a guaranteed win yet. Here's another example. A survey with a margin of error plus or minus 5% shows that 42% of participants reported preferring a shopping trip to Sun Valley Mall versus Newbury Mall. If the population of shoppers that serves the two malls is 272,000 people, what might be the least number of people that prefer Sun Valley Mall, and what might be the greatest? So we're looking at how do we actually interpret that. So least is 42%. This is our guess with a margin of error of minus 5, so the extreme is 37. When we turn that into a decimal, so 0.37 multiplied by 272,000 people, we get at least 100,640 people. I'm not doing well on numbers today. Weird. But the most, we're going to do the same thing. 42% plus the 5% is 47. We'll turn that into a decimal, 0.47, and then we'll multiply it by the number of people, and we get 127,840. So that's a pretty big difference. We're talking about a difference between these two of like 27,000 people. If you're running a mall, that may be your entire income. That may be huge. Part 3. Looking at newspaper or magazine articles containing sample survey results or statistical displays. In other words, how not to get caught. Sometimes in newspapers and magazines, we find things with margin of error. Sometimes they don't even mention it. And then kind of get away with that, but it's a little bit shady when they do. So, for example, a local newspaper article entitled More Beets Than Meats discusses more people switching over to vegetarianism. The article says in 100 people surveyed in 1998, 8% reported being a vegetarian. In a similar survey taken in 2000, that number grew by 50% to 12%. The margin of error in this survey, by the way, is plus or minus 3%. It's a great time to invest in produce companies because that number will just keep on growing. Now, okay, that's a good start. Let's look at the rest of this article. This means, by the way, that the actual results may have been as high as 11% vegetarians in 1998 and as low as 9% vegetarians in 2000. We may actually have this switched because the margin of error is actually so big. It's possible that the number of vegetarians actually declined. So even if they did increase by 50% during those 2 years, does not mean that number is going to continue. We just don't have enough data here. There's also no mention in this one of any of the sampling method. So the method they may have used may have been really awkward. For example, let's say you decided to sample people based on who showed up at a farmer's market. Is that going to be an accurate sampling? Probably not. Last one, analyze and interpret statistical data organized and displayed in a variety of forms, justifying conclusions. So I'm actually going to pause this one and start our next video. Thanks, guys. See you soon.